Hello students, welcome to YouTube channel LINGA REDDY Chemistry J. NEAT. Structure of the atom we were discussed in the last videos, particle nature of EMR and wave nature of EMR. So what is the difference between particle nature and wave nature? Some few points again we can recall here. See, the particle nature is quantized, wave nature is continuous. The wave nature is like this, particle nature is like this, particles are there. It is a localized, it is spreading. Okay, the wave nature is how it is spreading, we know that spreading like this. Here, the particle nature could not explain the diffraction and interference, but wave nature explained diffraction and interference. Diffraction means you know that suppose one wave is like this is there, so other wave is in opposite direction. So if it is trough and crust is there, it will be collapsed, it will become a line. That means, see one example here, two sound boxes, speakers, you keep it front this side, another speaker you make it front this side. If both are in opposite direction, you will get only noise. You will get only noise. There is no music. Okay. So this is the diffraction and interference. Interference is, suppose one slit is there from the one slit. If particle nature is there, the light is moving like this straight only. But you may able to see that this area also light will be there because the slit is after coming from the slit, it will spread like this. Okay, so these things can explain by only wave nature. These could not explain by particle nature. So Max Planck, see here, medium is required for wave. You may observe that on the river or sea, you can see that waves, how the waves will spreading like this. Okay, this wave velocity and speed is depends on the depth of the sea and wind power and so many other factors are there. But here no medium is required, so the velocity of all particles are same. It may be frequency, wavelength is different, but speed is same. Next, to calculate this particle nature, to study this, we have to know that mass and size of the particle, momentum and kinetic energy, these things we will measure. To measure this wave, to study this wave nature, frequency required, wavelength required and amplitude required. Okay, then initially starting in before 1800, Sir Isaac Newton, he proposed the particle nature, completely particle nature. But later Maxwell and Huygens, they proved that wave nature due to this reflection, refraction, polarization, Doppler effect, these all effects are supporting this wave nature. Maxwell and Huygens. Maxwell, these scientists given around 1900 before. 1900 and this before, wave nature is very popular. Later, Sir Isaac, Einstein and Planck, these scientists proposed that this electromagnetic radiation EMR has particle nature also. They shown some proofs. Compton effect, black body radiation, photoelectric effect, these effects are explained by the particle nature. Okay, even though they accepted that wave nature is there, so particle nature also. That's why they told that the wave is not continuous. They told that this is the waves, these are the waves, particles, discontinuous. And these waves are like this. So these are moving like a wave, but it is not continuous. These all are particles. The each particle is called photon. Each particle is called photon. This photon has fixed energy. Fixed energy. So that is quantum. Okay, quanta means all, plural, many. So the single photon energy is called one quantum. This is the quantized, it means a particular energy is there. Okay, this particular energy, whenever the frequency, the wavelength is changing, then the energy will be changed. Okay, the particles are same, the particle amount of energy, individual energy is same, even though when the wavelength is changing, the energy will be changed. E equal h nu. This is the overall concept of wave nature and particle nature. See, if you are not getting, then again once you pause the video, once you go back and watch it, because this summary, you know where you get it, this two theorems comparison, this explanation you cannot get it by any videos in YouTube. Okay, now so finally we came to know that EMR has, electromagnetic radiation has wave nature as well as particle nature. What is that? EMR, electromagnetic radiation. Of course it has already electric field and magnetic field. Okay, electric field and magnetic field. In the last classes, starting classes, we discussed that this magnetic field and electric field, each one is perpendicular, the propagation is in another direction. Okay, so now we are going to discuss this theory applied to matter. This theory applied to matter. Who applied that? The dual behavior. Okay, so the dual nature of matter or the wave nature of electron is given by de Broglie. In 1924, French physicist Louis de Broglie suggested that if the nature of light is both that of a particle and wave nature, then this dual behavior should be true for the matter also. Already before 1924, they came to know that EMR has wave and particle. वो Einstein बोल दिया, Einstein and Planck, wave and particle. Okay, so now same theory he applying for matter. So EMR is not matter. Once you have to be clear about this, it is not matter. EMR, light is not matter. Okay, the same theory he applied to matter. That is the credit of this de Broglie. According to de Broglie, the wavelength lambda of an electron is inversely proportional to its momentum p. Momentum means, in the last class also we discussed, momentum means mass into velocity. Okay, P equal to m into v. Angular momentum mvr. In the last video you can see that electron is moving in the circular path, right? So the lambda inversely proportional to 1 by p, that means lambda inversely proportional to 1 by mv. Lambda equal to h by p also we can write. Here h is the constant, that constant is equal to Planck's constant. Here p is the momentum of electron, so mass into velocity. Okay, now here one derivation is there. You can see this derivation. Lambda equal to h by mv. So we know that kinetic energy equal to half mv square. Okay, then I can write it 2 ke equal to mv square. Then mv chahiye na, so I am multiplying with m and dividing with m, so 2 ke, then mv equal to 2m ke under root. Yes, mv के जगह पे 2m ke substitute कर सकते. Then this is the proof. Lambda and kinetic energy, de Broglie wavelength, if you want to calculate, if they given kinetic energy, so from this formula you can calculate easily. Okay, if they give you the velocity and mass, it's fine, otherwise you can calculate from the kinetic energy also, like this. From the de Broglie equation, it follows that the wavelength of particle decrease with increase in velocity. When velocity is increasing, the wavelength will be decreases of the particle. Moreover, a lighter particle would have longer wavelength than the heavier particle provided velocity is equal. That's why big car is there. The car also moving like a wave, but you cannot identify because the wavelength is very smaller. इतना तो दिखते नहीं है. Suppose electron is there, the electron is moving like this. The big wave is there. So easily we can identify this is the wave nature. So the smaller particles are clearly visible in wave manner, but this is not applicable for macromolecules like heavy particles. This is the one reason. Then, if a charged particle Q is accelerated through a potential difference V, it's the important formula, from rest, then de Broglie wavelength is just Ke equal to QV, a stopping potential. We learned that. Where we learned this? The photoelectric effect. Okay, here suppose one electron is moving like this. If you want to stop this electron, so you have to apply some potential difference. So this energy is kinetic. This electron is moving means it has some kinetic energy. ये kinetic energy को equal amount of opposite energy is there, then only this electron will stop. So kinetic energy equal to Q into V. Q is the charge of the electron, V is the voltage how much you are applying externally. So K equal to Q V. So this formula it comes like this, lambda equal to H by 2m QV. बस K के जगह पे QV लिख रहे हैं हम. Why we are writing means this is the stopping potential. De Broglie concept is more significant for microscopic or submicroscopic particle whose wavelength can be measured. मैं अभी बोल दिया वो कार के लिए it's not applicable, only small particles के लिए. The circumference of the nth orbit is equal to n times the wavelength of the electron. Then 2 pi r equal n lambda. That means we know that Bohr's क्या बोला था वो electron is moving in a fixed path. Okay, अभी पता चला है it is moving in a wave manner. Okay, so it would be in a particular, ये ऐसा नहीं होता है. ये see here it's not matching. Okay, this is the wrong. So what is the correct then? So this is the correct one. Okay, so here it's matching properly. How many waves? The particular waves are there. ये तो small radius. Another orbit is there. Another orbit में another. So any particular number of waves are present. This is the total circumference equal to 2 pi r. The 2 pi r equal to n lambda. It may be 2 lambda wavelengths or 3 lambda wavelengths or whatever. कुछ है. The circumference of nth orbit is equal to n times of the wavelength of the electron. That equal to 2 pi r equal n lambda. Wavelength of electron is always calculated using de Broglie calculations. Wavelength of electron is always calculated using by de Broglie equation. Example, one question. Two particles x and y are in the motion. If the wavelength associated with the particle x is 4 into 10 power minus 8 meter, calculate the wavelength associated with the particle y if its moment is half of x. Moment तो दे दिया, ठीक है? So moment, what is the formula? Lambda equal to h by p is the moment. Okay, x particle and y particle के लिए moment ये है. Okay, then moment is x में आधा है. Yes, So py equal to half into px. तो एक हिंट दिया है, ठीक है. Then you compare this to lambda x by lambda y. Take this step. Lambda x by lambda y equal half px by px. Yes, actually lambda x by lambda y equal to, just you apply the same formulas 2 times. Okay, then lambda x by means h by px by h by py. So h will get cancelled, then py become py by px. py के लिए क्या लिख सकते हैं हम, half px लिख सकते by px. Same step is given here. So lambda x by lambda y equal to half, then lambda b already you know that 2 lambda, so 2 into 4 into 10 power minus 8, that means 8 into 10 power minus 8 meter is the wavelength of y. Understood? You can calculate like this. Next, Heisenberg uncertainty principle. The Bohr's theory is failed due to 2 reasons. One is the electron uncertainty position, and the second one is dual nature of the electron. Okay, these 2 theorems he did not consider because that time these people not discovered that. Okay, Bohr's theory considered an electron as a material particle. Its position and momentum can be determined with accuracy, but when an electron is considered in the form of a wave as suggested by de Broglie, it is not possible to ascertain simultaneously the exact position and velocity of the electron. More precisely, at a given instant, since the wave is extending throughout the region of space. Okay, so Bohr, what he told that one fixed path is there, but the electron is moving like the wave nature. How can you identify that? How can you say that the electron is moving in a fixed path exactly from this distance? We cannot tell. So because of this, so he could not explain. Next, in 1927, Werner Heisenberg presented a principle known as Heisenberg uncertainty principle, which states as it is impossible to measure simultaneously the exact position and exact momentum of a body as small as an electron. So the smaller particle position and the momentum simultaneously we cannot calculate. If you calculate exactly position, the momentum will be different. If you calculate exactly momentum, the position will be different. Okay, so the certain values we cannot calculate. The uncertainty of measurement of position delta x and the uncertainty of momentum delta p, or delta p का हम लिख सकते हैं m delta v also, because p equal to mv, are related by Heisenberg relation as delta x into delta p is greater than or equal h by 4 pi. Okay, this one we can write like this also, delta x into m delta v is greater than or equal h by 4 pi. But whenever we are doing the numericals, generally we will take it is as a equal, we will solve the questions. Okay, what is this delta x and delta p? Delta x means the difference. Okay, the uncertain value. Okay, suppose from here to here the distance is, I am telling that 1.5 centimeter. ओके 1.5 सेंटीमीटर में हो सकता है कुछ मिलीमीटर तो वेरिएशन हो सकता है. ओके 0.01 सेंटीमीटर तो वेरिएशन हो सकता है. सो दिस स्मॉलर वेरिएशंस, okay, that is delta x, like that the momentum variation is delta p. Okay, these are the wrong values we can say. Whatever we are predicting, इतना तो मिस्टेक होने का चांसेस है. Delta X, delta V, uncertainty products. Okay. So for an electron mass already we know that 9.1 into 10 power minus 28 grams. The product of uncertainty is quite large. Okay, delta X, delta V is greater than or equal to H, so Planck constant है 4 pi m. 4 pi m. You can see here, if you substitute all those values, 0.57 second per gram approximately. इतना तो variation होगा delta X and delta V. Okay, when delta X equal to 0 is there, that means exact position if you find, obviously delta V will be infinity, as well vice versa. That's why it is not possible दोनों accurate calculate करना. In this case, the bigger particle having considerable mass, the value of uncertainty product is negligible. The value of uncertainty product is negligible. किसका? Bigger particles के. If the position is known quite accurately, that means delta X is very small, delta V becomes a large, and vice versa. In terms of uncertainty in energy, delta E, and uncertainty in time, delta T, this principle is written as similarity. So delta E and delta T is greater than or equal to H by 4 pi. Okay, two formulas are there. So majorly we will use that first formula here, position and momentum. So from that they derived another formula, delta E and delta T also similar. Then Heisenberg replaced the concept of definite orbits by the concept of probability. Then from this Heisenberg uncertainty principle, later we will discuss that the electron is moving around the nucleus, तो सही है, लेकिन not exactly like a line. Okay, probability is there, so electron इतना दूर में हो सकता है. Okay, maximum probability is there. The maximum probability is only known as orbital concept. Now we will get it, orbital. अभी तक we know only orbit. Okay, orbit के अंदर orbital रहता है, वो orbital depends on this shape, electron density, probability, shape. Now we can discuss one question here. Why electron cannot exist inside the nucleus according to Heisenberg uncertainty principle? Diameter of the atomic nucleus is the order 10 power minus 15 meter. That is also Fermi also we can say. The maximum uncertainty in the position of electron is 10 power minus 15 meter. The maximum uncertainty. इतना से ज़्यादा नहीं होगा. The mass of electron 9.1 into 10 power minus 31 kilogram. If you substitute those values here, delta X, delta P के जगह पे m delta V लिख सकते, then H by 4 pi. Then if you substitute those values here, we are getting 5.8 into 10 power 10 meter per second. Delta V. This value is much higher than the velocity of light and hence not possible. This value is light velocity to 3 into 10 power 10 centimeter per second. Meter में है तो 10 power 8 meter per second. Okay, so this is the higher value than the light. That's why it is not possible. Right? Some questions are there. These questions you can solve. Yeah, take it. This is the homework. One question, and the second question, one more question I will give you. Just you pause this video, okay, and solve this question HW. These two questions you solve it. Of course, here solution is there. This solution you solve it, and these two questions you send. Okay. Bye. Thank you.